Hello and welcome to our presentation, Dairy Housing, Where Do We Go From Here? I'm Dan McFarland, Agricultural Engineering Educator with Penn State Extension based in York County, Pennsylvania. Joining me today is John Tyson, another Extension Ag Engineer based in Mifflin County, Pennsylvania. Average milk production per cow in the United States has increased dramatically and in a linear fashion for the past few decades, with no inclination of stopping. Improvements in genetics, better nutrition, and improved cow management techniques have led to this increase in milk production per cow. But facility improvements has also contributed by providing more comfort and a healthier environment to help cows better express their genetic potential and improve longevity. To perform at their best, each cow requires an environment that offers excellent air quality, a dry, comfortable resting area, good access to feed and water, a confident footing, and protection from weather extremes. In addition, caregivers need a safe working environment to observe cows readily, easily move, sort, and isolate cows as needed, as well as manage feeding and manure collection in a timely manner. Before we look at some current facility design standards and consider what might be needed over the next decades, let's look at how dairy housing has changed over the past few decades. For this presentation, we will focus the discussion on typical loose housing designs used in the Northeast and Upper Midwest. To keep this presentation within the time allotted, we will also focus on the housing area only. Freestall or cubicle systems became popular in the late 1960s as dairy producers looked for ways to move away from tie stall barns and loose housing using bedded packs to increase their herd size and find ways to make the tasks of feeding, milking, and caring for cows easier. This is a plan drawn in 1966, a two-row plan, freestall plan, with a silage bunk located on the side of the building. A milking center was located on one end of the barn. This had a double 3 herringbone parlor. And notice that there was optional space for a shed for storage or a heifer housing located on the predominant wind side of the building. This layout, again, was two-row tail-to-tail freestall barn with 62 freestalls. The freestalls were 4 foot by 7'6". Natural ventilated building with 10-foot high sidewalls with the ability to open the upper 2 feet of the sidewall. The ridge was 9 inches wide. For feeding, there was a 2-foot wide bunk, 154 feet on the wall side, and it's an elevated silage bunk that provided about 30 inches of feed space per stall. And there are 2 frost-free water locations. The alley adjacent to the feed is 13 feet, and between the freestalls was 8 feet wide. Here's a 4-row plan, tail to tail, with a feed silage bunk in the center of the barn. The milking center located at one end of the barn, and note that the feed alleys also double as a holding area as needed. So in this layout is 114 freestalls, same size as the previous plan. However, it's only an 8-foot sidewall with that 2-foot hinged opening at the top of the sidewall and a 16-inch open ridge. It's a 108-foot elevated silage bunk that provided about 23 inches per stall, and there were 2 waters provided per group, or a total of 4. The same alley widths for the feed alley and about a 9-foot alley between the freestalls. Here's an example of what a barn at that period might look like. Here's a plan in 1979. It's a 2-row barn as well, with approximately 57 stalls, or 64 stalls, I believe, in this particular case, with a silage bunk located at the center of the building now, and also a portion that's a hay feeder, and a milking center at one side. This layout, even though it's several years later, now has freestalls that are 4 foot wide and 7 foot long, a 9-foot sidewall with a 2-foot hinged opening at the top and a 9-inch open ridge. There's a 60-foot elevated silage bunk at the center with approximately 23 inches per stall, and also a 16-foot hay feeder available from each side, so about 6 inches per stall. But only 1 frost-free water located in this plan. The alleys provided between the bunk and the freestalls are about 11 feet 10 inches. Here's an example with some modern improvements with the sidewalls and freestalls, but gives you a basic idea of the layout of this particular plan. Roger Grout, a Penn State agricultural engineer in the 1970s, first developed the Penn State drive-through barn. It's a 4-row design with, rather than an elevated bunk in the center, it used a drive-through so that mobile feeding could be used to deliver the feed. The milking center is located outside the freestall barn rather than within it, which provided better ventilation to the holding area and just made cow movement a lot easier. Here's an example of a Penn State drive-through barn, again with some modernization that's done over the years with the free stalls and sidewall ventilation. This particular plan featured 4 50-cow groups. The free stalls, again, were 4 feet wide, 7.5 feet long, a 9-foot sidewall, even though it's a much wider building, with that 2-foot hinged opening at the top, and a 10-inch open ridge. The center feed delivery alley had feed mangers on either side that were 3 feet wide and approximately 112 feet in each group, providing about 27 inches of lineal feed space per stall. And there was 1 frost-free water per 50-cow group. The alley adjacent to the feed was 10 feet wide, and between the free stalls was 9 feet wide. In 1982, out of Massachusetts came what was known as the high density, the 6-row high density barn. And of course, at this period of time, they were looking at making the construction of these buildings very economical, trying to get as many cows in as few square feet as they could. And so this was a design that came out of that period. There were 6 rows of free stalls adjacent, or 3 rows of free stalls on either side of a drive alley, with that drive alley down the center, and again, the milking center outside of the housing area. We look at this, and in this particular plan, there were 4 95-cow groups. Free stalls along the outside row were 4 feet wide and 7 feet long, but the interior head-to-head free stalls were each 4 foot wide and 5.5 feet long. The sidewalls are 10 feet wide with that 2-foot hinged opening at the top and a 12-inch open ridge. The center feed delivery alley for each group was about 144 feet, providing about 18 inches of feed space per cow. And then there was per stall, and there was 1 frost-free water per group. Alleys were 11 feet wide adjacent to the feed area and 7 feet wide between the free stalls. In the mid-90s, and then again in 2005, we created what we call the dairy idea plans, updating some of these designs that we've just reviewed. This is a 4-row tail-to-tail version of that particular design. This is a example of that design. The stalls are tail-to-tail, and then the feeding area adjacent to that. We also, looking at this plan drawn in 2005, now this particular plan had 2 62-cow groups. Stalls are now 4 feet wide and 9 feet long. We have 14-foot high sidewall, and it's an adjustable opening of about 12 feet of that 14-foot sidewall. The ridge opening now is 36 inches wide. The center feed delivery alley is now 20 to 24 feet wide, and also there's 2 within that. There's 2 3-foot wide flat feed tables, providing about 27 inches of feed space per stall. And now there are 3 frost-free waters per group. Alleys adjacent to the feed in this plan are 13 feet wide and 12 feet wide between the free stalls. Here's an example of a 2-row head-to-head free stall facility, which has really become more popular as the sidewalls got higher and more open to provide more weather protection and shade. In this particular layout, same number of groups. This free stalls now are 8 feet wide because they're open front free stalls, and cows will tend to share lunge space in this particular arrangement. 14-foot high sidewalls with 12-foot adjustable opening and a 36-inch open ridge. The feeding area, again, 20 to 24 feet wide center delivery alley with 3-foot wide feed tables. But because of the head-to-head versions in the freestall arrangement and the crossovers, we now have about 33 inches of feed space per stall. The alley here is 14 feet wide adjacent to the feed alley, simply because we have free stalls exposed to that alley now, and 11 feet along the outside wall. Also was improved was the 6-row freestall design shown here in this particular diagram. Here's an example of what that looks like. In this group, in about the same lineal space as we had with the 2-row tail-to-tail, we now can put 87 stalls rather than 62. The free stalls are 4 foot wide and 9 foot long along the outside wall, and then the head-to-head stalls are 4 foot wide and 16 feet curb to curb, allowing that 8 foot per stall. Side walls will be anywhere from 14 to 16 feet high, with a 12 to 14 inch opening, or 14 foot opening, and a 36-inch open ridge. 20 to 24, just like the others as far as feed delivery alley, but now because of the 3rd row of free stalls in the facility, getting more cows in there, the amount of feed space is about 20 inches per stall. Feed alley 14 feet, and the rear alley, now that the stalls are tail to tail, increased to 12 feet. So just looking at the cross section of these barns through the years of what we've just described, where the original 2-row tail-to-tail barn was about 84 feet wide, our most recent design has increased to 108 feet wide. As far as sidewall height, it went from 9 feet to 14 feet. In the 6-row, or this 4-row plan with 160 stalls, 280 cow groups, because of increased stall length and also the addition of crossovers, it's increased the length from about 20 feet, from 172 feet to 192 feet. In the 6-row facility, we've gone from 90 feet wide with that 1982 design to about 123 feet wide with our 2005 design. And the sidewall height has increased from 10 feet in 82 to 14 in 1995, and then 16 feet in 2005. Here again, very compact design, getting 160 stalls in there, but increased stall length and the increased use of crossovers have increased the length from about 120 feet from in the 1982 version to 148 feet now. So looking at the period that we looked at here from 1966 designs to 2005 designs, we can see that milk production continued on that linear curve, or that linear line, and increased productions from somewhere around 8,000 pounds per cow now up to a little over 19,000 pounds per cow. As I mentioned earlier, the trend in milk production continues from here. John, why don't you take the next portion of the discussion?
All right, well, thanks, Dan. I'm going to pick this up and zoom in a little bit on that milk production curve from, say, 1960 to 2019, our last numbers. And just to give us a little bit of reference, let's put on some other facts that are the rest of the ag world and the rest of the world were on in that same curve. In 1963, John Deere introduced the 40-20, which at least for guys like me that grew up kind of bleeding green, that was the mothership of all tractors through the 70s and 80s. But some other things along the way: the first space shuttle launch in the early 80s, the first iPhone released in late 2000, I think it was around 2007, all the way up to the first robotic rotary. So the rest of the world has been moving along with us as this production has increased. And where is the top? That question keeps getting asked. And you know, in my career the last 25 years, you know, I can now say that 30,000 pound rolling herd average is no longer a dream, and bulk tank averages of 100 plus are not the exception. They are starting to become what everyone wants to strive for. And just to take it one step further, what if we look for what's the record? At least in 2017, there was a cow in Wisconsin set at that time a record of 78,000 pounds on a 1-year lactation. If you boil that down, that means she was averaging in excess of 110 pounds of milk per day. That is just a tremendous amount of milk that we got to think about these girls creating in a day's time. So, you know, little bit more of a cartoon approach to it. Where is the top? You know, are we going to start to see cows with 3 udders or 4 udders, or maybe the cartoon on the right here where the cows can't walk because the udders have gotten so big? Where is the top? And I'm not really here to answer that question per se today. I think we can identify that the genetics of the cow are there. They are increasing. They are improving every day or every year. Now the question is, can the genetics of the management and their consultants keep up? You know, we know the cows can do it. Now, can we do it? So what does higher production mean to those cows? Well, we know that that's going to be higher dry matter intake. They got to eat something to make that milk, probably higher water consumption. We know there'll be more heat produced. We may increase lying time, so change some of the behavior of the cows. And there's going to be more manure produced per cow, at least. Maybe not as a total, as we seem to have fewer cows making more milk. Maybe we'll actually make less or the same amount of manure total, but we know that per cow we're going to produce more manure. And what are those cows going to need from a housing? Well, I don't think that the cows of today are no different than the cows back in 1965, and are probably no different than the cows will be in 2050. They're still going to need 4 basic things. They're going to need air, which comes through ventilation. They're going to need feed and water to create that milk, and some type of shelter, protection from weather extremes, whether that be extreme heat or extreme cold. Those are the basics of life, and how well we do those 4 things will help drive us up that lactation curve. And speaking of shelters, you know, when animals are brought inside, we really need those situations inside need to be equal to, if not better, than outside conditions. This is all part of domestication of animals and how we treat and house them. So if we look at each one of those individually a little bit, what are the current standards of ventilation, or that air? Well, 3 things. We provide dry, clean air to those animals throughout the year. We're trying to remove moisture, heat, gases, pollutants. And the third one there is a big one. We remove the extra heat produced by animals, particularly during hot weather, that excess heat due to milk synthesis. Ventilation here, and looking at the Northeast, the natural ventilation pretty much the norm. However, it is dependent on those natural winds and natural temperature differences. We also see an awful lot of mechanical ventilation here in the Northeast, particularly in our tie stall barns, and we starting to see more mechanical ventilation in large barns in the upper Midwest, with cross ventilated barns or tunnel ventilated barns. So, you know, that's kind of the 2 terms. One thing about mechanical ventilation, very predictable, because we're designing around a known air exchange from the fan, and we design inlets and or outlets. Natural ventilation of the future. I guess the question becomes, how far can we push natural ventilation in modern dairy housing? Can natural ventilation achieve what we need it to? As shelters continue to get wider, Dan's history showed that to us, and shelters are having more cows inside them. This drive for more cows inside a given shelter. What does that do to natural ventilation? Once again, we got to remember, natural ventilation is trying to get inside and outside air quality the same while remove moisture, gases, odors, pollutants, and particularly excess heat as we deal with heat stress. So let's go back and look at the equation that at least gives us some idea of predicting natural ventilation. May not be an exact number, but it gives us at least some relative values to look at. And those 3 important things are building orientation, the area of the inlet, and the building's exposure to those natural winds. Those 3 elements are what drive natural ventilation. So if we look particularly at orientation, we know that being perpendicular to those prevailing winds makes natural ventilation better and more attractive. However, there is an issue in the Northeast, particularly here in Pennsylvania in the Northeast, of orientation perpendicular to our prevailing winds that are westerly also exposes us for more sun penetration from the east or from the west. So we have a direct sort of argument between orienting around sun orientation versus ventilation. Just something to keep in mind as we design new buildings. What about building exposure? Getting exposure is very important, and I think this in the future may drive us away to go to new sites. higher sites with better elevation, better exposure. This kind of becomes topography driven, natural topography and geography as to how we're going to get exposure. Also, obstructions due to air or due to other structures, we need to get separation. And particularly if we look at that in this diagram, we can see that these naturally ventilated freestalls that are 400 feet long, we're dealing with needing up to 250 plus feet of separation between them to really get natural ventilation as far as exposure. So is that a limitation when we look at natural ventilation in the future? The other big driver of natural ventilation is this sidewall opening. As you can see from the photo on the left versus a photo on the right, history has proven we know this. We've figured this out. We're doing a better job. We're no longer building buildings 10 feet high with a small 2-foot hole. We're striving for 14, 16, 18 feet of height and trying to open up as much of that sidewall as possible to still have structural integrity. Really, the goal we're striving for is to try to get that sidewall opening somewhere in the 11 square foot per cow inside the barn or more. And we really can only count one side of that structure. There's only one side that's really going to be an inlet. And this can be an issue for these barns as they get hot or get wider and have more cows inside them. But once again, we've known this. We figured this out, and through history, Dan's steps we've went through, we can see over here that our sidewall opening per cow has continually gotten better. In these last designs of 4-row barns, we've achieved that 11 plus square foot of opening. However, the 6-row barn still struggles to provide that opening size at 16 feet of height. So are we going to see a drive for higher barns? Or are we going to weigh that off against some other type of mechanical or other ventilation example, such as mechanical, and deal with wider, denser populated barns? Just something to think about as the future comes. One thing I think we need to do, one thing we can work out is this natural ventilation factor, where we take those 3 factors of opening, orientation, and exposure, put them on a scale of 1 through 3 and equate them, and then we add those together. And as you can see at the bottom, if we come up with a factor of less than 4, so if everything is in the best column, we have possibilities of good natural ventilation. If we wind up in excess of 8, more medium and poor situations, perhaps mechanical ventilation is needed for that structure. Or if it's a new structure, we have to go back to the drawing board if we really want natural ventilation and rethink what we're proposing. So what's going to happen in the future of ventilation? Like I said, I think cows are still going to need air. We still need that fresh air. We still need to remove moisture, heat, gases, and pollutants. I think we're going to put more emphasis on not only day-to-day, but hour-to-hour consistency of air quality within the structure. So that means more automatic controls and allowing a computer system and artificial intelligence to run this system so that we can maximize consistency. Cows love consistency. And from a ventilation, we're going to focus even more on heat removal from the shelter and heat abatement of individual cows, of that cow within that building. So we increase, repeat there. So can natural ventilation achieve these goals through added heat removal and consistency? Will complete mechanical ventilation be something? Do we have to be, it seems to be more consistent. However, at least here in the Northeast, it may come at a higher cost, particularly operational. So maybe we'll see combinations of seasonal combinations of mechanical and natural ventilation, i.e. natural ventilation in the winter or cooler months, something like tunnel, cross ventilation, something like that in the summer where we're more mechanically driven. That does have a higher capital cost because now we're actually building 2 ventilation systems, but we're trying to maximize operational costs for each season. I think we'll maybe see more of that. From a heat abatement side of it, I think we just need to go back to the beginning and remember where cows come from. They are homeothermic, meaning they have a consistent, constant body temperature. trying of 101.5. And they are of Northern European origins, meaning they probably are going to be overtaxed more by heat than by cold. They're naturally adapted to a cooler, more temperate climate. And if we throw up an equation that predicts heat production based on milk production, and look at those two. We see this 75-pound cow, which equates to about a 23,000-pound lactation. Her heat production per hour, BTUs per hour, is somewhere around that 5,000, 5,300 mark. But if our goal is to have more 100-pound cows in that herd and have 30,000-pound lactation curves, now we've added another 1,000 BTUs an hour to deal with per cow. That has to be removed from that shelter in some way, removed from the cow first of all, and then removed ultimately from the shelter itself in order to have heat abatement. So these numbers bear out that with higher production comes more heat, and Berman in 2005 made this statement that cow moving from 75 pounds per day to 100 is going to lower her threshold, her temperature threshold, heat stress threshold, by about 10 degrees Fahrenheit. So therefore, these high producing cows are going to be heat stressed earlier in the summer, earlier in that heat curve than our lower producing cows. We're going to have to put more emphasis, not less. Thought I'd throw in at least global warming or climate change, however you want to refer to it. And this statement made by St. Pierre that extra metabolic heat is actually going to be as much as 2 to 4 times greater an issue than global warming. So even if we acknowledge that global temperatures may go up by 1 to 2 degrees, just the production metabolic heat itself from increased productivity is going to drive us to heat abatement faster than the environment. Why is that? Why is heat abatement such a big deal? Well, if we go all the way back to these feeding equations from 1976, we can see that they're predicting maintenance requirements based on temperature of an animal needs more energy as the temperature goes up because she's naturally trying to get rid of some of that heat on her own. She's increasing her respiration rates. She's increasing her heart rate. She's sending more blood to the surface, rediverting her resources to try to dissipate heat. So her projected dry matter intake to maintain milk production is going to go up as the temperature goes from 70 to 100. Well, we know in reality that's not how the world works. And as the temperature goes up, dry matter intake is actually going to go down. Well, she still needs this extra energy to cool herself. So her way of combating this is she's going to stop making more milk. Her maintenance cost, her maintenance energy requirement is actually going to go up, not down. So we have to be able to help her get rid of heat better so that she has a lower maintenance cost and can keep driving that high milk production. These are some curves that show how steep this curve is. The higher producing animals, in excess of 88 pounds, this is a very steep and severe drop off in dry matter intake. If we have cows that are yielding less than 50 pounds, we actually do, at least in this study, see that increase in dry matter intake so she can cool herself off. So if this is the cow we want to work with, we've got to figure out some way to flatten this curve because, if we're satisfied with 44 pounds of milk per day, she can do it on her own. But I don't think that's what we want to see. What about behavioral heat stress consequences? I mentioned that things are going to change because of this production, but from a heat stress standpoint, now we're driving lying time down. And this also influences lameness issues, not just production. But if the average hour she lies down, that extra hour equates to 2 or 3 pounds of milk, we're talking 6 to 9 pounds of milk just off of the lying time loss due to heat stress. So that covers ventilation, the air side of it. I'm going to let Dan take over and talk a little bit about the evolution of the freestall.
Okay, thanks, John. As we saw in those diagrams earlier, freestalls have changed over the years. And the first freestalls actually were developed out in Washington back in the early 1960s, and were really kind of very interesting to people coming and looking at them, that cows would actually use these. Through the 70s and 80s, the design criteria was, well, let's try to reduce square footage to reduce costs, and we'll provide a space for the cow, but we want to keep that stall clean, so we don't want her, to use too much of that stall. And so typically these stalls, and depending on cow size, would range from anywhere from 44 to 48 inches wide and 7 to 7.5 feet long. In fact, there were some recommendations that looked as facility or free stall lengths as short as 6.5 feet. And here's an example of it. Looking at this diagram on the upper left here, you can see that the outside row of this 3-row facility, the stalls were 6 feet 6 inches. And then the head-to-head version, even though there was an obstruction in the middle, we're down to 13 feet 2 inches. And the comment made in this paper, you can't read down in the very well down in the lower right, but I'll blow it up for you here. Stall length of 6'10" is too long for this large Holstein. 6 feet 6 inches is suggested. And that to me is just unbelievable. We know what short free stalls, how cows behave in short free stalls. They don't get up in their natural posture. They don't use the entire stall. They might be hanging off the back. And then we see increased standing and perching in the stalls because the stall length just doesn't allow the cow to get in and to rest comfortably. From 1990, some encouragement as far as stall length. We started to look at 8 feet, and then now we're recommending anywhere in the range of 9 to 9.5 feet along an outside wall, or if it is a closed front free stall, because we've realized that in order to get up and down comfortably, cows need to lunge forward in order to do that, and we need to provide that room in the length of the stall. And so our most recent recommendations do allow for that length and provide that. The early free stalls were built out of wood, and then soon after that, metal versions became commercially available. But also the structure was not in the right place. Again, it was trying to control the cow and keep the stall clean rather than have her get in the stall and rest comfortably. It seemed to be the idea behind that design. We've come to know that that structure is also very important in getting that cow to use the stall properly, allowing for that cow to get into the stall, all 4 feet in the stall, with her head under the neck rail, go into the reclining posture, providing that lunge forward to do that, allow them to rest comfortably while they're there, and then lunge forward to rise and exit the stall comfortably. So the position of that neck rail and the divider became very, very important in allowing that. Some of the earlier designs that we saw in the 70s and 80s, the neck rail was typically in the range of about 3 feet above the stall base. And then the neck rail would be anywhere from 12 to 24 inches from the wall. They didn't even measure on the cow side. It was more from the wall because these stalls required some lateral strength, and that's what the neck rail was used to do in that period of time. And then also, again, to keep cows clean, or at least thought was to keep cows clean, was she needed to hit that rail pretty hard when she was getting up to encourage her to back into the alley and put any manure and urine into that space rather than onto the stall. You can see on the right here, this renovation that was going on in this farm where they were renovating the stalls. You can see that the neck rail is now 12 to 14 inches higher than what the original free stalls in that barn were installed, more to the correct, what we consider right now, the correct dimensions for modern cows. Also coming into the market is flexible free stalls to allow cows a little more freedom of movement when they're in the stall. If they happen to bump up against them, it's not going to be a hard pipe working against them. There's going to be some flex there. And I don't have any opposition to this particular type of stall. I think it can work very well, but let's not change the dimensions of the width just because these stalls will flex. The cows are going to occupy the same footprint resting in this type of stall as what they require in the other type of stall. And so I don't think we need to try to get more stalls in the barn by scrunching things down just because these stalls move. Also, the resting surface has changed. The original free stalls were usually earth-based with a layer of bedding on top of it. Unfortunately, the earth base would dig out relatively soon because the cow's action of getting up and down in the stall. And so it was very difficult, especially with these stalls that were anchored in the curb, to maintain these stalls, so they became very rough. And so there was another motivation to stabilize the stall base, and it was done in a number of ways. Here on the right, you'll see actually tires buried into the earth base in order to stabilize that base. There were some other recommendations that came out using a hard rubber mat with a thin layer of bedding, and or else perforated steel mats with bedding, and even hardwood plank with bedding. And while they did a very good job of providing a more stable stall base, unfortunately they weren't very comfortable. And so the modern designs have really gone to providing comfort on that and encourage that cow to rest and keep her comfortable while she's there. I think cows probably prefer a generous bedding layer over other types of stall bases that are available. That 4 to 8 inches of bedding conforms to the shape of the cow, provides good traction, and provides a real good degree of comfort. And I don't think cows really care whether it's sand, straw, sawdust, or dry manure solids that they're resting on, as long as it gives them a good cushion and conforming as they're resting. Mattresses have become very popular through the late 80s and 90s, and I think they're a good addition. They do provide a stable, relatively stable stall bed, but they only provide some percentage of the comfort that cows really like in that generous bedded. And so it does require an adequate amount of bedding on top of these, not only to provide that extra cushion and comfort, but also to help keep the stall dry from any milk leaking or urine that would get onto the stall. In the future, I think they'll continue to evolve. I don't think we've stopped. I think the stall size and structure will adjust to the size and needs of the cow. I mean, we have, as long as we have good dimensions, the dimension data from what the average or the typical cow will be, we can use those dimensions with these formulas to come up with the type of stall dimensions that will be needed for the cows of the future. So I don't have any real problem with that. I think we need to continue to observe and study cow behavior and see what's really needed, what they tend to prefer and use, and create designs that allow for that. There also may be the need, especially in larger herds, you might want to create groups that have the number or stage of lactation cows together, similar cows together, of number of lactation and also the stage of lactation, and maybe design the stalls more tightly to their recommendations, or the stage of gestation. Even in the dry, as cows through gestation, generally their girth is a little bit larger, and so we're going to need to look at that as well as herds that might have one or more breeds or two or more breeds within them. We need to realize that the smaller frame cows are probably going to require a different design than the larger frame cows. I think, again, in convincing people to adapt stall management practices that provide the comfort, promote cleanliness, increase longevity, to get those cows to use the stalls when they need. And also, as I travel around, I keep hearing about this normal overcrowding, that it's normal to overcrowd, and I think that may go away as these cows have more increased needs for rest in the future. And there was a study done in 2000 up at Cornell that I think is very interesting and points to that. In a 4-row shelter, they had a couple groups of cows where they had 20 cows in a group. Then it was one stall to one cow. But in another group, it was 30% overcrowded. So there was 26 cows in the same number of stalls. And what they found is that the average stall use over a 24-hour period for the non-populated group or the evenly populated group was 61%. And in the 30% overcrowded group, it was 91%. Now, if you're taking a test, 91% is better than 61%, but in this case, it's not. Because what it means is that there are probably cows, well, I know there are cows standing and waiting for their turn to rest, which is going to provide the opportunity for greater lameness in that particular situation. So I think we want to, relook at overcrowding and see what works best for a particular group of animals as well as a particular farm. So John, why don't you take care of the feeding?
All right, thanks, Dan. Looking at some of the feeding evolution as we went through it, we saw that in the 70s and 80s, if we go back to our designs and what we talked about back then, we had elevated J bunks and H bunks. Usually they were elevated somewhere around 24 inches. Sanitary steps were a thing. But what I wanted to point out was the linear feed space was about 20 to 30 inches per cow, mostly because we were feeding silage and grain separately. We did not have the TMR. As we move into the 90s up to our modern designs, or what we call modern designs, we've changed that feed table to a more grazing position. We've identified that as an animal behavior thing that needs. So we've lowered it down to a normal grazing height of 2 to 6 inches. And some of our designs are a little more liberal than others, but we're somewhere in that 18 to 30 inches, depending on the exact design. And we're usually always talking TMR. So where does that lead us? Where does that want us to go in the future? The future of feed design, what will look different, what's going to change? Well, I'm not sure that I know a whole lot about what's going to change, but let's go back and once again look at this animal behavior. And from Dufries, we can see that he's saying that a typical cow likes to consume their dry matter in about 3 to 5 hours total, spread throughout the day and spread out over about 7 to 12 meals in any given day. So the size and distribution of those meals impacts total dry matter intake and can also influence rumen function because of slug feeding, if that's going on, or keeping that rumen pH fairly even. So our goal is to achieve consistent maximum dry matter intake. We want to have more frequent meals, so spread over a long period of time. So smaller meals spread over a long period of time, more consistency, more turnover at the bunk. Cows get to the bunk more often. But what happens when we've studied what happens behaviorally at bunks that have lots of competition? Cows reduce their feeding times. So they now are increasing their feeding rate, meaning they're eating more per meal and fewer meals to get to the same dry matter intake, thus consuming fewer, larger, longer meals, which is exactly what we said is the opposite of what we want to do to drive dry matter intake. So competition at the bunk is going to be one of those futuristic things that's going to have to be looked at if we're trying to maximize dry matter intake. What can we do to change competition? Feed space keeps coming back around in lots of discussions, has been for a long period of time. If we take a look here at a typical post and rail feeder and how many cows like to be in here, what do they feel comfortable? What's their behavior tell us? Well, we've noticed that about 5 cows in this nominal 12-foot spacing seems to work out. If we count them 1, 2, 3, 4, and 5, and we push some simple math of 144 inches, 5 cows, they are trying to tell us that 28 inches or so is about where they feel comfortable eating with their partners. So what are we doing in our designs that is influencing this against this normal, what they would at least find acceptable? So what does this mean really to that 3-row or 6-row high density shelter? Well, we know that the 3-row is very popular because of economics, particularly capital economics. We can squeeze the same number of cows into a much smaller footprint. You see here 2 barns of equal stall number and about 33% less length. It's a little wider, but it's not near as long. And particularly here in the Northeast with our topography, our cost of excavation on some sites to get space, this 3-row has become very popular, but that has come at a cost. It's a benefit to capital cost, but operationally we've pushed that from a 29-inch, which is that previous slide said where cows might be pretty comfortable at. We've squeezed that down to 19, and we've dramatically increased the competition at the feed bunk. So where does that mean? Does that mean that the 3-row barn will at some point in time become operationally obsolete? It'll still be there, it still works, but at what production level have we kind of maximized its ability? I don't have an answer. I just say that as a future question. What about some other things future in the feeding? Will automation really become popular? Well, we see it on a lot of different farms. We see it on farms now, things like the Lely feeder, and there are others. But what does that mean? And I think the first thing that hit me was when Dan showed me some pictures of a barn with one of these that has signs about unmanned vehicles and restricted area and beware of safety instructions. Just something I had never really thought about when it comes to automation. But what does this mean not only to facilities and how we accommodate them, but what does it mean to you folks as nutritionists? How do we feed cows? Do we feed them differently when we're doing it with automatic feeders than what we do now with the TMR? Just questions that are going to come in the future. If we switch gears a little bit to another feed ingredient, which I think is the most important feed ingredient, mostly because it's the largest feed ingredient, that's water. We know that cows drink more pound for pound than they eat. And future milk will be the same as today's milk. It's still going to be 87% water, maybe a little less. Maybe we'll get more components in it, but we're still going to be, the majority of that milk is water, and it has to come from somewhere. We know that water drives milk production, or vice versa. Production drives water intake, but it's a straight line. How much water space? I think this number will continue to be a good number to strive for. 15 to 20% of the group can milk at one or drink at one time, which gets us around 3.5 to 4 inches of water space. Another thing is going to be that recharge rate. Having water flow to these individual waters of 6 to 9 gallons a minute so that waters don't go dry. I think that may be more important than anything in the future. I think these water stations are going to get bigger. They're going to have more water flowing through them, and we've got to think about that from the beginning. We know that these are popular places for cows to gather. They like to drink water. They like to socialize. This is the water cooler of their office. So in future designs, we're going to see more space, not less space, to accommodate this gathering, to allow cows to come and go around these popular spots. And I think water access is a big, important thing. Some of those designs Dan showed you early on had one water station, and that was one water cup per group. Now we're talking 3, 2, 3, 4 waters per group of animals. This is a quote from Jim Spain from Missouri a number of years ago, that cows should be no further than 50 feet from water. So we've known that for a long time. I think now we just have to start to act on that. And my hope is that in the future, as we look at design, we're going to bring water to the forefront, and we're going to think of it early on in the design factor, not as an afterthought. So drinking water in the future is going to be more, not less. I hope it's design or earlier discussions in design rather than later as what is popular now. I think maybe we'll have recycled water from other processes. Will we have more milk concentration on farm, so we ship less water to the processor? Then we can recycle that water back into the cows for drinking water. Can we reclaim water from manure systems? These are all questions that the technology at least somewhat exists. It's now going to be getting that technology to a price point, into an application, a cost, a price point mostly, and operationally, can we afford to do it on a farm size scale? Questions, future of water. What about transition cows? I think, just another topic beyond feed and water. Dry cows only represent about 15 to 20% of their herd. So why do we spend so much time talking about them? Why worry about them? Usually we just stick them in an old barn or a forgotten housing system. Well, I got this slide a number of years ago from Bob Vincent at Penn State, and really what it says is that, these herd genetics, this kind of sets where our production is genetics. And we can have a lactating program that kind of bumps around on one side or other of wherever our lactation bar is. But it's truly dry cow programs, transition cow programs, and management that set this bar. The real difference between a 25,000 pound herd and a 30,000 pound herd really may be its dry cow program that allows those herds to reach their genetic potential. And I think as we strive for higher production, we're going to focus in on these management things that can drive us to the next tier, drive us up to that next step. Another way to look at dry cows are, it's only 25 to 30%, but every cow in the herd hopefully makes it through this multiple times in her lifetime. She's going to be a dry cow several times. She's going to be a transition cow several times if we can keep her around for 4, 5, 6 lactations. And really, for every cow in the dry cow program, there's probably about 4 other cows that are out in the herd paying the bill for the cost of that transition system. So every cow is going to be affected by your transition facility, your management, your style, your program. So transition cows are going to be more and more important, not less important. Dan, you want to talk a little bit about a special needs cow or
Yes.
special attention?
Well, I think every cow is special and they need special attention, and they're going to need to be isolated from the herd occasionally for examination, breeding, treatment, pregnancy check, hoof trimming, or any convalescence that might be needed. And so we need the ability to do that relatively easily. And we have that opportunity from the cows returning from the milking center. They can use either manual or automatic gates to guide them into an isolation area, and then they can be taken to a short-term care area. And what we define that as is provide that observation and care within an hour so that they can be released back to their group. We need adequate space there and a restraint method that allows to minimize stress of both the cow and the caregiver, and then they can return to their group or long-term isolation pen if they need to. And so here's an example between the housing area and the milking center where there's a traffic lane to bring them to the milking parlor. There's a sort gate that guides them down the return lane. There happens to be a foot bath here too as well. And then there is a palpation rail included in this particular facility with work lanes on either side, or they can be sorted to this cow lane, which directs them into these individual short-term isolation pens so that they can remain within their group per se in this isolation area. The herdsman office is nearby and all the supplies they need, and in this case there was even a tilt table to take care of any hoof trimming or whatever might be needed for that between the regular herd foot trimming. Long-term isolation is greater than an hour, so we need to provide water, feed, and resting space in that area as well as the restraint method. And then the ability to take care of removal of a non-ambulatory cow and provide good bedding and so on that might be needed in that area. So some of the other farm management related influences that might influence facility design is that I think farms have gotten bigger. They'll probably continue to get bigger as far as the number of animals and number of acres. Some other things we're seeing is single owner, multiple sites. Because it's more convenient as far as land availability and facilities that might be available in that way. Or would we look at consolidation, maybe multiple neighboring farms working together, sharing equipment, and even going to the point where maybe they have one milking site, one dry cow site, replacement heifer site, those types of things might be considered. So each one is specialized, maybe bringing a little more efficiency to the entire operation. Some off-farm influences that certainly aren't related to the facility but could relate to the facility is the consumer and processor wants and needs. What is the processor going to be doing with the milk? What does the consumer want to consume when it comes to dairy products? That might change how things are handled on the dairy. Environmental regulations, I'm sure, will continue. And then there's that consumer perception of confinement housing. What is that going to do? Is there going to be pressure that way to maybe look at more strongly at some animal welfare requirements? And I think they're very important. I think we need to keep in mind the animal of every design we make. And in the back of my mind anyway, when I started to create things, is as far as facility design, is we certainly want to provide these 5 freedoms which were put together by the UK Animal Welfare Council in '93. And basically it's provide freedom from hunger and thirst so that they have water and a diet so that they can maintain good health and vigor, and then freedom from discomfort so they have an appropriate environment to keep them protected from weather extremes, as well as provide comfortable resting area. freedom from pain and injury, and that's where this, individual sorting or treating that cow individually, do we have the ability to rapidly diagnose her problem and treat it in that way, and the freedom to express normal behavior, whether it's grooming each other or resting comfortably or being in the company of the animal's own kind. And then there's this freedom from fear and distress, ensuring conditions and treatment that avoid this mental suffering in a cow. And I'm not sure how they measure it, but one thing I know in my career is that early on in the past 30 or 40 years that I've walked into dairy facilities, cows would go the other way. I didn't take it very personally. It's just that there seemed to be a lot more stress. Some of the newer designs, giving more space, providing more comfort, more feed availability, water, all those things, I think come into play. Now, when I come into an animal group, I'm more of a curiosity than anything, and they want to come see who I am. And so I think that has to do, it's part of it because we've reduced stress in those cows and reduced that fear, and it's been a good thing. So with that, that's the end of our presentation. If you're interested in this topic, or you'd like to have any questions of anything we talked about today, or would like further information on what you might be considering, or have any good ideas that you might provide us, we'd certainly appreciate it. Here's our contact information, and we look forward to hearing from you. Thank you very much for taking the time to listen to this presentation. I hope you found some information that will be useful in your work. Take care.
Thanks all.